Hi, everyone. I'm Rachel, the host of Technically from Source. Every Monday through Thursday, we take 20 minutes to cover hot topics in commercial architecture and design, including new product releases, designer stories, industry leaders, and the impact of design. If you're tuning in live, know that you're automatically on mute, but you can use the chat feature to ask questions. You can also find a video recording on demand at tothesource.com or subscribe to the podcast on Apple or Spotify by searching Source Snack Break. Today is Thursday, September 17th, and we are covering basically all these topics in one with Evan from the TallWood Design Institute in Corvallis. And I am so excited to chat with you. We are going to talk about mass timber construction and construction with wood just in general. But before we get into that, can you tell us a little bit about your background and then a little bit about the TallWood Institute in Corvallis?
Like it may have, but anyways, I am Evan Schmidt. I am the outreach coordinator for TallWood Design Institute. I'll talk a little bit about the institute first. It is basically a research coalition or collaboration between two different universities in Oregon. That's Oregon State University and University of Oregon. And really specifically within those universities, it's 3 colleges and sort of 3 disciplines. Really, to keep things succinct, it's kind of combining faculty in wood science, faculty in civil engineering, and faculty in architecture. So what we focus on is on basically the state of the art in terms of using wood as a construction material for advanced buildings, really especially like larger buildings, 5, 6, 8, 18-story timber buildings. And my background is originally architecture. So I studied architecture in my undergraduate, kind of worked in sort of a variety of faculties of design for a while. And then I came back to school. I got my master's degree in wood science. And my research focused on cross-laminated timber, which is what you see in these pictures, along with some glue lam.
Nice. So, and I want to, if I recall correctly, Corvallis has a big U.S. Forest Service presence. Are they involved in some way, or am I making that
up? Oregon State University has a really good forestry program. It's like #2 ranked in the world.
Yeah.
So TallWood Design Institute is actually based at College of Forestry. That's where we reside. We're kind of nested within College of Forestry, and U.S. Forest Service basically has a building kind of nestled up against our college. So yeah, forestry is really big at our school.
Yes, it is. Well, you're in the middle of a forest, so it really helps. Yeah. Sweet. Okay, so let's talk about wood construction. What is it that you all study at TallWood, at the TallWood Institute, in terms of what is wood construction, especially as it pertains to commercial construction? Give us the rundown on what it is that you study and why, essentially, and then how you interact with architects and designers regarding that research.
Yeah, so I mean, this is a good picture to kind of talk about that. I mean, you'll probably notice that this is not what you would typically think that you're seeing when you think of wood construction. I mean, at least the average person, I think, usually thinks of stick frame or light frame construction, dimension lumber, 2x4s, maybe 2x6s, balloon framing, big hollow walls that are lightly framed in timber and then have a bunch of fiberglass infill or whatever. So this marks a very distinct departure from that kind of construction, mostly in that it's an entirely new kind of series of materials and products. It's sort of loosely termed mass timber. It's been kind of a catchphrase in the last, especially couple years. But mass timber is kind of a loose term. It defines products. They have to be engineered wood. So if I take a step back, a typical wood product, like dimension lumber, has pretty variable performance, right? Wood is a natural material. It's very heterogeneous, which means every piece of wood behaves differently. Different species, different pattern of growth rings. You've got knots, you've got various slopes of grain. So there's a huge quality control sort of mechanism that underlies wood products because of that, because you have to be able to sort and sort of define what you're using in order for designers to use it. Engineered wood products are superior in the sense that they use typically lower quality wood. You don't need to harvest old growth wood to get quality wood. and then you basically break it down and reassemble it into a more homogeneous, more predictable product.
Got it.
So mass timber is basically just a giant version of an engineered wood product. And it originated really in Europe about 25 years ago. So like late 90s, mid 90s, like Switzerland, Austria, Germany is really where this started being pioneered, these really big engineered wood products. And they are different because they behave totally differently from what we think of as standard wood. And that ranges from like seismic performance to acoustics to how they behave with water. You can see some rain accumulating on the surface here. And then importantly, fire. So massive wood components burn totally differently than light frame, which is a really big deal. I mean, a lot of people worry about fire, and that's something. So anyways, I don't want to ramble too long, but yeah, what we do is we are helping to sort of fulfill the necessary science component of how these products work. Because you have different species, you have different climates, you have different building codes, and like these systems are evolving. So we do basically all the research kind of behind the scenes to help designers know like, hey, this is how this stuff works, and now we can use it.
Got it. So it's kind of like if you go to Home Depot, there's like the whole row of like 2x4s and 2x6s, and those are the ones you're talking about that they're sort of like, this is the old school way of doing it, the sort of traditional American, like, and that is kind of problematic because all of those pieces of lumber are independent and they behave very differently, and there's a lot of quality issues. Whereas this mass timber or engineered wood products is basically like massive, like OSB or massive plywood, which get their strength and their performance from being an amalgamation of different little parts, and together they form a more cohesive whole that sort of perform together. Is that kind of accurate?
Yeah, I mean, and like I should backtrack a little bit and say like the dimension lumber you buy, it is pretty predictable because there's this whole mechanism that creates grade stamps, right? So you say like this is number 2 or better, number 3 or better. So there's this whole mechanism that defines what wood is going to behave like, and it gets kind of sorted before it ever gets to you. But the benefit is that, yeah, you can use potentially like lesser grade, like lower quality timber in engineered wood products. So instead of like cutting down a bunch of old growth, you can use potentially like even forest thinnings, like things that don't typically have value in the economy traditionally, can potentially be used in wood, like engineered wood products, and it gives an economic outlet for these things that also makes like managing forests more economically feasible for governments.
It's a twofer.
It's kind of a twofer, yeah. It's kind of a twofer.
And so it sort of reminds me, like you just said, that when it comes to like 2x4s and dimensional lumber, they're fine to use because there's already standards in place to grade them. And it sounds like there are not those processes in place quite yet for engineered products. And is that sort of what you guys are all working on, is trying to create those standards so designers and builders can feel confident that what they pick up off the shelf is going to perform the way it's supposed to?
Yeah, there's kind of an element of that. So like, traditional engineered wood products like plywood, there are standards, those are well integrated into design. But for newer products like cross-laminated timber, which is what we're seeing here along with glulam, those standards don't necessarily exist. So it's kind of like you need that data because it's kind of like a piecemeal process. So now that they do, I mean, there's a standard for CLT in the United States. It's called PRG 320, and it defines everything about quality control, and it defines how it needs to perform. And then you can certify a product. So a manufacturer can say, I make CLT out of spruce pine fir, and my quality control system like basically makes sure it meets these standards, and then it has basically specified design values that designers can then use.
Perfect. Okay. So let's talk a little bit about why this sort of matters right now and why it's an upcoming trend. I feel like this is something designers are hearing a lot about, mass timber construction, CLT construction. We're seeing, at least in Portland, we have a couple CLT projects that have been built. Talk a little bit about like where you're seeing the sort of market come from, or what the trends are, and how TallWood sort of reacts to those.
Sure. Yeah. Well, I mean, the market is really quite driven by specifiers, right? So it's really like owners and oftentimes architects, I would say, are really the kind of preeminent and predominant specifiers and drivers of these materials in the built environment. So I mean, I would say the precedent of having, particularly British Columbia, like start adopting this a little earlier than us, and then also Europe really helps to sort of set the stage for designers to say, like, here's something we can point to. And there's a number of reasons why they're interested in it. I would say, like, to really boil it down succinctly, you've got the economic incentives and then you've got the environmental incentives, right? So I think, like, you know, mass timber is really appealing to a really wide audience of stakeholders because it's perceived that it sort of bridges the bipartisan gap and has both economic and environmental incentives. So on the economic side, local governments say, well, hey, look, we have our own forests. We have access to millions of acres of premier structural softwoods, like in the Pacific Northwest. We've got Douglas fir, strongest structural softwood in our backyard. And we are exporting fiber increasingly to other countries that then manufacture that wood into an added value product and sell it back to us. So why don't we basically invest in our own local economy, use our own materials to make our own building products? It just makes sense.
Yeah.
And then on the environmental side, there's sort of, I mean, numerous ways to talk about it. The main way people talk about it relates to carbon and climate change.
So hot right now.
Yeah, exactly. Very pertinent to what's going on. So, like, basically, you know, more conventional building materials for public buildings or larger buildings are going to generally be reinforced concrete or steel. And I mean, not only are they extremely energy intensive to produce these products, and they're typically produced across the ocean, but they're also extremely extractive. They're non-renewable. I mean, you have to mine construction sand and limestone and gravel aggregate and ore, and then refine it and so on. So it's perceived that a local economy that uses wood, not only, you know, you save on basically that entire sort of like production process, but the wood itself actually is renewable and so sequesters carbon. So about half the weight of wood is sequestered carbon from the atmosphere. So if you look at like biogenic life cycle assessment of timber buildings, they tend to have net negative carbon emissions. So there's excitement, you know, because of that. That's one of the big drivers.
Yeah. So sidebar, designers, if you're interested in hearing a little bit more about the embodied carbon of concrete, our Transparency Tuesday this week was actually with Jordan from DEQ, who studies that exact thing. So if you're interested in that, definitely check that out, because he got really into the weeds about why that is the case. But I also wanted to chat with you about the economic factor. I mean, especially in the Pacific Northwest, we already have a lot of lumber mills. Some of them are more active than others. Are those facilities things that can easily be transformed or retrofitted to do production for this type of material?
I guess the answer would be like yes and no. Like most of our mills, like if you look at European mills, they tend to be much more flexible. Like they're outfitted in order to kind of deal with different sized logs, and they can produce really like kind of different size like lumber. Most of our mills are really kind of geared, like if it's a dimension lumber mill, it's really geared towards our like 2x market.
Yeah.
We kind of have these like set sizes, and they really are kind of geared to only be able to handle certain size logs. So most mills can't do anything too big at this point because we're not really doing big old growth at this point for dimension lumber. And actually really like what we're looking at more and more is smaller and smaller diameter. So there are mills that are basically kind of looking at retrofitting to be able to handle smaller logs, because that plays into the forest restoration angle. Like forest thinnings, you know, really small diameter logs are typically really difficult to use because there's just a lot of work for a smaller amount of material. But if we can create economic incentives to basically utilize thinnings from forest restoration to basically mitigate wildfire, then it kind of obviously helps make that happen. And so, engineered wood products are kind of like perfect for using those sorts of.
Got it. Yeah. So can you talk a little bit about like questions designers always have when it comes to mass timber construction, and how you at the TallWood Institute sort of either research those questions or address those questions or work with the designers, because this is kind of new and we're not super familiar with it. Like, what should designers know in terms of, you know, if they're putting into their project or if they want to talk to their client about it? Like, what are those talking points that they should know?
Yeah, I think like in some of these questions that are here, like really a lot of times boils down to like, hey, how sustainable is it? And like there's questions surrounding forestry, like forestry is can be pretty confusing. I mean, you have different ownership regimes. You've got private ownership, you've got government ownership, state, federal, and then you have different management sort of like regimes in different localities, and then you have different certifications that kind of say like, hey, we go above and beyond.
Yeah.
So it can be really confusing, kind of like about sourcing, the supply chain. So I think like there's a lot of work going into that these days, both at TallWood as well as up in Washington. Basically, I think that's Carbon Leadership Forum doing a lot of stuff with this. Basically looking at like, hey, like what really is the carbon story? And so that's a big one that comes up, and we talk about that a lot. We talk a lot about forestry and carbon. You have resins here. So like resins is a big question, kind of like people tend to worry about air quality. So you know, like basically like formaldehyde, isocyanates. And then you have like, is wood actually strong enough? So people do commonly ask about like seismic performance, like, hey, can you really have like an 18-story wood building? Like, how does that work? And so, yeah, I mean, there's all of these have nuances. And usually the answers surprise people. Fire is another big one. I brought that up. Like, I mean, we got this picture here of somebody measuring the cross section of a burnt CLT concrete slab. Fire is really big. I would say that's like probably the main thing that comes up on an ongoing basis. People are like, they're worried about using a combustible material.
Yeah.
And I can go into the sort of the details of that. It's really interesting. I mean, the sort of like big picture metaphor I like to use is like, if you're going camping, you want to start a fire, what's the first thing you use? And then
the tiny little
thing. Use kindling, right? Because the surface area to volume ratio is a lot higher. You need something can't burn without oxygen present. So when wood burns, it's basically volatile compounds that are leaving the wood as it's getting heated up that mix with oxygen and heat and then catalyze to produce flame.
Okay.
So if you have a lot of surface area, you basically have a lot of exposure to oxygen and makes something burn a lot hotter and faster. Really massive products like this, they burn really slowly because they char, and the char basically naturally insulates the wood from oxygen, and then you have a very predictable rate of combustion with these products. So
basically it releases all of its stuff that could burn very quickly, and then once that burns, the char sort of protects the rest of it from burning and makes like it sort of seals it off essentially.
It kind of like seals it off. Yeah, totally. And like engineers have actually been designing for big pieces of wood for a long time. Like basically the way they do it is they say like, we know wood is going to burn. If you use a big piece, it's going to burn at like X number of inches per hour under like a full raging fire. And so what they'll do is they'll design for a certain size. They're like, okay, structurally we need like a 12-inch by 12-inch column. But we have to have a 2-hour fire rating for that column. So what we're going to do is add X number of inches to the perimeter of that column. So that
gives you the range.
Exactly. So like in theory, then it burns for 2 hours. And after 2 hours of burning, it's at its original design specification.
That's amazing.
And a lot of times like these things will self-extinguish anyways, if depending on the fire. But that's a whole other story. Yeah.
So before we move on, can you talk a little bit about the resins and engineered wood products? I know that comes up a lot. We get a lot of questions from our designers at Source about that. Can you dabble into that a little bit before we head out?
Yeah. So totally. You know, a lot of the concerns about like formaldehyde resins, for example, came out of plywood. So there's always going to be basically like a ratio of how much resin is used, how much wood it needs to get through to be off-gassed, and then how long it off-gasses for. And then there's the chemical question. So, you know, I'm not a chemist, but we work with chemists all the time. The resins that are typically used now have a much lower volatility. Basically, they're more bound up directly into the wood, so the rate of off-gassing is not really on par with where the original concerns were. That being said, we're still constantly doing testing for air quality and like what kind of like off-gassing these products have. There's interesting research also looking at just sort of dispelling some of these concerns by using alternative resins. So one of the former faculty of our wood science department, Kai Cheng Lee, patented a soy-based resin for wood products. So it's basically like formaldehyde isocyanate-free soy-based resin. I mean, that's interesting because that gets into different territory. I mean, you're getting into industrial agriculture at that point. And I don't know how much more time I have, but anyways, yes, there's, I could talk about that for a long time.
Awesome. So what I'm hearing is if designers have questions about the resins, they should definitely reach out to you and you could chat about it.
Yeah, feel free. Yeah, there's a healthy conversation going on about that. So.
Great. Okay, so it looks like we are almost out of time. So designers, if you have any questions for Evan, feel free to chat them in now. In the meantime, you can always head to our website to get more information and start working with wood immediately, since we're now all excited to do that. If you are tuning into the podcast, we'll put the same link in our show notes so you can check that out as well. In the meantime, Evan, I'm super excited about this. And the good news is we're going to be talking to you again soon about wood and Transparency Tuesday, one of our Transparency Tuesday series. So designers, if you want to sign up for another snack break, you can smash that register now button or head to tothesource.com. Evan, it sounds like the work you're doing is super interesting, and I'm really excited that you're doing it, especially these days. And I will hopefully chat with you. Well, not hopefully, I will chat with you again soon about how designers can make an impact in design using wood construction. Awesome.
Yeah, totally. I really appreciate the time. Thank you, everybody. And we have a bunch of stuff going on this fall too. We do like research seminars, so if people are interested in learning more. We also have a Wood Science 101 for designers course that's starting September 29th. So
that's
if
great.
people are interested, please email me.
Awesome. We'll see you there. Thank you so much. All right, we'll see you.
Thanks, guys.
Bye.